In this section, we are going to talk about number system. We'll try to understand what is number system. We'll start with what are real numbers. Then we'll talk about imaginary number. Then we'll talk about what is number system. And then we'll take a Venn diagram representation of real number. And finally, we'll take some examples. So let's talk about what is real number. To start, for real number, we'll start with a natural number, which is also known as counting number. And natural numbers are generally represented by n, and numbers like 1, 2, 3, which we use on day-to-day counting purpose, are natural number. We all know about another number called 0, and if you include natural number and 0 together, what you get is whole number. Whole number is generally represented by W, and hence it is a combination of 0, 1, 2, 3 and so on. So whole number is nothing but natural number, but it includes 0 as well in it. Now, what is left after whole number is negative numbers like -3, -2, -1. And if you combine whole number with negative numbers, what you get is integers. So integers are basically collection of whole number plus negative number. They are also called as positive integer, 0 and negative integers. So integers are basically positive or negative numbers including 0 that have no decimal or fraction. So far we came up to integers where we do not have any decimal and fraction included into it. So what comes next is fraction. Now fraction can be represented as decimal as well. If you include integers and fraction together, what you get is rational numbers, which generally get represented by Q and can be represented as P by Q, where Q is not equal to 0 and P and Q belongs to integer, positive or negative. So that gives you rational number. Fractions that can be represented as P by Q, where Q is not equal to 0 and P and Q belongs to Z, are called rational numbers. Also, one thing which you need to remember, these rational numbers are fractions for which decimals, if you try to convert them into decimals, they will either terminate or they will repeat. That means they will follow a similar pattern. Irrational numbers, generally represented as Q dash, and is a combination of a square root of 3 to a square root of 3 and pi etc. are the examples, and they are the numbers which, when you try to convert them into decimals, they are either non-terminating or non-repeating. So well, it's not either, they are non-terminating and non-repeating. That means they will never terminate and they will never follow a repeating pattern. And when you combine rational number to irrational number, what you get is real numbers, which are collection of rational number and irrational numbers. Next, let's talk about imaginary number. So we have discussed all of it so far up to real numbers. What is still missing in it is imaginary number, which are generally a square root of negative numbers. We'll discuss more about this in the higher classes, but for now you just understand, if I have to include a square root of -1 and -3, they are imaginary numbers. And when you include imaginary number to real number, that it gives you entire number system. So what is number system? A number is a mathematical object used to count, label, and measure. In mathematics, the definition of number has been extended over the years to include such numbers as zero, negative numbers, rational number, irrational numbers, real numbers, and imaginary numbers. Now here are some examples. 1, 2, 3, -4, -5, 2 by 5, 3 by 8, square root of 2, pi, 0.10110111011110, and so on. These are some examples of numbers. Now let's talk about how do we represent real numbers in Venn diagram. Any real number can be represented in Venn diagram. Here is an example of natural number, which is basically number used to count, like 1, 2, 3. And then when you include 0 in the universe of natural number, what you get is whole number universe. So natural number plus 0 is what gives you whole number. Now if you include negative numbers, what you get is integers. If you include fractions, which gives you either terminator, that means their decimal value will terminate, or they start repeating, that means their decimal values repeats. So rational, all the fractions which gives you either terminator or repeater decimal values, when you try to break them into decimal, what you get is collection of rational numbers. And then you have irrational number sitting outside that Venn diagram so far, and these are, when you try to convert them into decimal, they are non-repeating, non-terminating values. And when you include all of this, what you get is real numbers. Now let's take an example of rational number where you see it either terminate or repeats. Here are some examples. Find the decimal expansion of 10 by 3, 7 by 8, and 1 by 7. When you try to do for 10 by 3, when you divide them, you get 3 times 3 as 9, and what you get is 1 left. You add 0, put decimal, you again multiply 3 times 3 and you get 9. And you will see that 3 times 3 get repeated even after decimal. In all the cases, you keep getting remainder as 1. And hence, you will see remainder keep repeating. Even decimal values keep repeating for divisor equal to 3. So this is one example of rational number where when you try to convert them into decimal, they repeats. They are repeaters. Now let's take another example of 7 by 8. If you try to divide 7 by 8, you can see that after certain division, you get 0 at the end. And you get remainder as 640 for divisor 8. This is an example where the decimal value terminate. This is a terminator example where when you try to convert 7 by 8 as decimal, they terminate after 3 decimal values. And hence they are rational number. Let's take another example of 1 by 7. When you try to divide them, you will see the decimal values doesn't stop. However, you will see the remainders and the decimal values will repeat after a certain point of time. Here is an example. You will see remainder comes as 3, 2, 6, 4, 5, 1, and then it repeat again as 3, 2, 6, 4, 5, 1 for divisor 7. This is an example where you will see it repeats a pattern after certain digit of numbers. Couple of points to remember. Remainders either become 0 after some stage, an example was 7 by 8, or start repeating themselves, example was 10 by 3 and 1 by 7. Now, if you see count of entries in the repeating string of remainders, 1, 2, 3, 4, 5, 6, it is always less than divisor, and then it starts repeating, right? So total number of count before it start repeating will always be less than divisor. So if I have divisor in 7, I know the maximum repeating value could go up to 6, which is the case with 1 by 7. However, in this case, count of entries in repeating string was just 1, which is also less than 3, which is less than divisor. Let's take an example of irrational number. These are the number for which the decimal value will be non-terminating and non-repeating. And here are some examples. Square root of 2, you will see it has value as 1.4142135630730 and so on. Like it is never ending, it is not repeating. Similarly, the value of pi is 3.1415926535897 and so on. So these are some examples of irrational number. Now there are two types of irrational number. One we call algebraic irrational number and another we call transcendental number. We'll discuss more about this in the next session. However, I want to make sure you understand we often represent pi as 22 by 7. But that is not an exact value of pi. It is an approximate value. So pi in reality is not equal to 22 by 7. Also, when we try to calculate the value of pi using an advanced computer, very high speed computer with advanced algorithm, we computed the value of pi over 1.24 trillion decimal places, and it was still not stopping. Thanks for watching. You can visit us on www.classisfun.com.